Next problem. An engineer analyzing a series of digital signals generated by a testing system observes that only 1 out of 15 highly distorted signals followed by highly distorted signal with no recognizable signal, whereas 20 out of 23 recognized signals follows recognizable signals with no highly distorted signals between. Given that only highly distorted signals are not recognizable, find the fraction of signals that are highly distorted. Fraction of signals means nothing but probability, right? Solution we will see. So we are taking the state. First one highly distorted, and second one recognizable. So H and R. So we are now forming the transition probability matrix P. So states xn minus 1, xn minus 1 present, xn is the future state, HR. So what is that? So that only 1 out of 15 highly distorted signals followed by highly distorted. If it is highly distorted, then it will give highly distorted. The chance is 1 by 15. So H 1 by 15. So balance what will get? So 1 minus 1 by 15. Correct? So 1 minus 1 by 15, that is taking LCM 14 by 15. So H against R, you will get 14, 15, right? The second one we are getting 1 minus first one, right? Next, whereas 20 out of 23 recognized signals follows a recognizable signal. So recognized, then recognized, RR. So 20 by 23. So the other one recognized, then highly distorted. So 1 minus RR. So you will get 1 minus 20 by 23. So 3 by 23. That is P. That is equation number 1. Next, now probability fraction that are highly distorted we need to find. So let pi is equal to pi 1 and pi 2. Pi 1 refer to highly distorted H, recognizable signal. Pi 2, that is R. And we know pi is equal to pi into P, which is equal to P, and pi 1 plus pi 2 is equal to 1. That is equation number 2. Now from 1 and 2 we are substituting the values of pi 1, pi 2. P is the 2 by 2 matrix, 1 by 15, 14 by 15, 3 by 23, 20 by 23, which is equal to pi 1 by 2. Left hand side normal matrix multiplication, 2 by 2 matrix, say 1 by 2 matrix into 2 by 2 matrix, you will get 1 by 2 matrix, and 15 that is pi 1 by 15 into pi 1, 3 by 23 into pi 2, equating to the right hand side pi 1. Second one 14 by 15 pi 1 plus 20 by 23 pi 2, equating to the right hand side pi 2. So first consider the first equation, 1 by 15 pi 1, 3 by 23 pi 2, which is equal to pi 1. So keeping pi 2 one side and pi 1 another side, so 1 by 15 pi 1 go to other side, right hand side, it will become minus 1 by 15 pi 1. Taking LCM, you will get 14 by 15 pi 1, right? That is equation number 3. Now we know pi is equal to, pi 1 plus pi 2 equal to 1. Therefore pi 2 is equal to 1 minus pi 1. That is equation number 4. Now comparing 3 and 4. So you will get 3 by 23, instead of pi 2 you are substituting 1 minus pi 1, equal to 14 by 15 pi 1. So grouping pi 1 one side and constant term other side. So you will get 3 by 23, which is equal to 14 by 15 pi 1 plus 3 by 23 pi 1. So taking LCM, so you will get 322 plus 45 by 345 pi 1, which is equal to 3 by 23. Therefore pi 1 equal to, grouping all the numbers, you will get 45 by 367, which is equal to 0.123. So if you want pi 2 is equal to 1 minus pi 1. Substituting the value of pi 1, 0.123, 1 minus 0.123, you will get 0.877. So we need the probability fraction of signal that are highly distorted. That is pi 1 we need. So pi 1 equal to 0.123 in percentage into 100, 12.3 percentage. For probability fraction of recognizable signal is nothing but pi 2, 0.877. So in percentage into 100, 87.7. Right? That's all. So we'll see in the next video. Thanks.